Welcome to the Deep Engineering Podcast, where we bring you real world insights from the architects, engineers, and authors shaping modern software. I'm Divya Selvaraj, the editor in chief of Deep Engineering, and your host. And today we're going to be talking about what it takes for experienced Java teams to adopt Kotlin in production settings. So we have with us José Dimas Luján Castillo, a mobile-focused technologist with 15 years of experience building Android, iOS, and Flutter applications, and leading teams across companies around the world. He has worked on more than 500 mobile applications, written over 7 development books, and taught at more than 25 universities across Latin America on programming, mobile development, and technology projects. So, welcome to the show, Jose. It's really great to have you with us.
Hi, nice to meet you.
Brilliant. And we are also joined by Ron Veen, a seasoned JVM engineer with over 20 years in the Java ecosystem. Ron has worked across domains ranging from mainframes to microservices, is an Oracle certified Java programmer and Sun business component developer, and currently serves as a special agent and lead developer at Team Rockstars IT. He speaks regularly at international conferences and has authored books on Java, cloud-native migrations with Jakarta EE, as well as on advanced concurrency topics, including virtual threads, structured concurrency, and scoped values. It's really great to have you with us here, Ron. A very warm welcome to you.
Well, thank you for having me.
All right. And I'd like to tell you that together, Jose and Ron are also co-authors of Kotlin for Java developers, published by Pact. And in this conversation, we are going to dig into their brains to explore how senior engineers and architects can make Kotlin a first-class citizen alongside Java. What changes when you bring Kotlin into existing JVM systems? How concurrency models, mobile architectures, and cross-platform strategies are evolving, and where they see the most practical wins and the biggest risks for teams making these shifts today. So let's get started. So, Jose, I'm going to start with you. So Kotlin has matured from being primarily an Android language to a broad JVM ecosystem player. For instance, roughly half of Kotlin users now utilize it for backend development as well. So, from your perspective, what are the biggest benefits Kotlin offers to today's senior developers compared to Java? And in what areas do you still find Java holding its ground?
When we start using Kotlin at Android, the difference was very obvious because we have too much verbose Java. Because Android is doing some things in mobile development with the Java characteristics. So, for example, it was very easy to see the real benefits. For example, null safety is automatic. So in this case, it was very, very fast. The interoperability with Java, because at the end, if you have a legacy code in other language, is so weird. You want to try a different language just because it's modern, even if you have details with the language, because you will have a lot of problems if you change to a new technology framework or language. So the interoperability at the beginning, obviously, we don't believe we have a good interoperability, but when we try it, we saw, okay, maybe I can do the next steps in my applications with Kotlin, but I don't need to fight with the legacy code, even if it's in other language. So I think in the second interoperability was a good point to start with Kotlin for mobile development. And obviously, we have another things as functional programming in a very easy way to add it or the synchrony. But I think that 2 points to start for any mobile development when we try to start with Kotlin is a good point. Well, at the end, we need to remember the first step for Kotlin was mobile development and was very easy to clear. It's a good start with Kotlin. But if Kotlin don't use this null safety, interoperability. Probably the adoption was slow or more complex for the people because, as I mentioned in the 2 minutes ago, the main problems they are still there, even if you change the language. So I think that's my point for this comment.
All right. Thank you so much, Jose. And Ron, like you to add your perspective on this as well. And also, I wonder how should engineers decide when to use Kotlin versus Java for when it comes to new projects?
Yeah, I think my experience comes more from enterprise and not so much mobile development. What I've seen there is, well, there's a natural eagerness from developers to learn new things. And like Jose said, when you switch from Java to Kotlin, it really feels, I don't know, it makes programming a bit more fun again. That's something I really found. I could see developers getting enthusiastic. I think one of the benefits is you actually have more concise code, so you write less code. And also, like mentioned, the code tends to be less error prone. Null safety is really a big thing. You can actually see that a lot of frameworks working towards that now, also with regard to new Java versions. But nullability will always be a thing in the JVM, and Kotlin takes care of that for us. Now, why would you adopt this technology? Well, I think that there could be a number of attractive points. Again, like I said, there will be less code, and less code is good. Less code to maintain. There's less errors in the code. It might make your development team actually more attractive to new hires because, you're using a very modern language. And we shouldn't forget, Java really evolved. Java had Project Ember, where it added a lot to the core language, like records and sealed classes and pattern matching, things that already were in Kotlin. Java gets them added slowly. They're getting added, but I think Kotlin is just always quicker with adding those new features that developers really crave.
Right. And Ron, I want to continue with you. So many Java veterans fall into the trap of sort of writing Kotlin in a Java style. What are some common mistakes, mindset shifts that Java developers need to overcome to write idiomatic Kotlin?
Yeah, I think that's the thing that we all got to at some point. We started with Kotlin and then we wrote it in this Java style, right? And this is really not what we should do. And it is a natural reflex, let's be honest, because first, okay, I want to do a new language, but I also have a project to finish or a task to finish or a sprint, to complete. And also, we're still trying to, write code in the way we know it and just use the little things. So that actually can kind of give you some problems there. But sometimes as a developer, you have to be willing to relearn the language. You know Java, and now you're going to do Kotlin, and you can do everything in Java style in Kotlin, but you really should try to relearn the language. So it's not a drop-in replacement. You really have to be willing to learn. I can remember I once pitched it at a project, and developers really got, okay, this looks good, this looks fine. And then just to force myself to really do it in a Kotlin way, I just tried to shrink the number of lines that were in there, and the original from 250 went down to under 100 or something. And that was not technically needed, but it was just, okay, how can I even leverage more of Kotlin's native way of doing things and make things faster? Yeah. So sometimes you just have to pick up a piece of existing code and decide to rewrite it completely and forget about everything you know about Java.
Right. Thank you, Ron. And Jose, it would be great if you could add some of your own perspective here and perhaps share some best practices to avoid Java-esque Kotlin and fully leverage Kotlin's language features.
Yeah, actually, as Ron mentioned, that's the thing. When we start with Kotlin, I think 99% of the developers we start just translate the code. And actually that's the problem, but it's part of the beginning, because obviously we have one line of code in Java and we want to see how I need to write this line of code in Kotlin. But later you hear about the benefits in Kotlin, and obviously if you are translating, for example, each line, you will see you don't have less code, you have the same code. In a different way, maybe it's easy to read, but it's the same code. But when you start asking that kind of questions, you will see the benefits, because you start trying to look inside about how is Kotlin doing that, and you will see 5 lines or 10 lines in Java, maybe it's 2 lines in Kotlin or 3. So you will see the real perspective from Kotlin, and this is the first step, I think, for look the good practices, for example. You will see that, for example, not only writing new lines or different, but the achievement for these cases. For example, the immutability first. You will see, okay, I need to think in immutability first, because it's a different way to start the problem. So, for example, you are automatic using good practices in the general programming world without do anything, because you don't know sometimes, or you don't have clear, we are creating Java, but we are not thinking in immutability first. So that's, for example, after a couple projects or some examples you are trying to execute, you will start seeing you are using good practices sometimes, uh, because it's natural here in Kotlin as immutability. But obviously now you can do that the same thing in other languages, even Java, okay? But you need to do something to have this in your code. In that case, in Kotlin, sometimes the good practices, you don't have to change the code to have it, because by default you have these good practices. And you will see a lot of that cases, not just the immutability, for example, the collections and streams, the lambdas. Lambdas is the same space. Lambdas is not as something advanced in, when you are learning in other languages. Obviously, it's not the first subject, the lambdas, for example. And here in Kotlin, when you are starting the code, you will see lambdas since the beginning sometimes, because and even you don't know it's a lambdas. You know it's a code, but later you will see it's a good point to start doing something. So I think that's a good and kindly way to start using good practices, and sometimes even you don't know you are using these good practices.
Wonderful. Thank you for your insights there, Jose. And now I'd like to get your perspective on concurrency. So, Java's recent releases have introduced virtual threads and structured concurrency to simplify multi-threading. According to you, how should engineers approach concurrency now? For instance, when building a high throughput service, how do you choose between Kotlin's coroutine model and Java's Loom-based virtual threads, Jose?
Um, well, I think the way maybe it's not the easy way to understand that, but I think if you are coming from Java, the concurrency, you can see it as a model. We have a definition about the how we can do some stuff, and the coroutines is a model to a structure with a structure to think about it. What is the important or the main parts for this? You have cancellation, you have propagation, you have the control of all the cycle. That's the thing. You don't need to think too much in the all the scenarios, because you have it you have the structure. So I think that's the main concern when we are trying to understand, because sometimes you need to think by yourself in all the scenarios, but no, in this case, the coroutines is very clear. You have the ingredients to start doing anything, okay, with obviously coroutines versus, for example, one case, virtual threads. You will have a way to a very simple model too, for example, is a very traditional. We have very clear, because the thread is an old way to do the things. We have an excellent things, but at the end they can work together because maybe you can use one for some specific problems, and you have other options for other specific things. It's not battle about who is better, because that's another thing. A lot of people, they are working, they want to know the faster way to do that, the less code to the way to do that, and it's not the cases about in this case coroutines. If you have some specific problems and you don't have the model, well, think about, we have coroutines, for example. But if you have a very complex situation, for example, and you need to put less complexity in your system, maybe you can use threads, for example. That's the thing. It's not too complicated to use, for example, the Java virtual thread, because if you have a very complex structure with layers, probably this is the answer. You can do that. But for example, if you don't have that kind of level of complexity, you can use Kotlin, for example, for other things. And at the beginning, obviously, the main com complexity is when you are using JVM to do that kind of task. The problem is you have a monolithic focus or scope for that. And now you don't need to think just in the monolithic way to have an answer. I think that's my comment for this.
Right, brilliant. And Ron, of course, I'd like you to add your perspective on that, and also like you to talk about how you see these two concurrency paradigms complementing each other in practice.
Yeah. Um, First, we should say that I think both virtual threads and coroutines, they basically also try to solve the same problem, which is basically like, executing async code, but make it appear sequentially in the code so the developer can really reason about, okay, what is the flow of my application? So there's not this thing called callback hell where we have like a million places where there are callbacks all through the code. Mm, Both systems, I think, really, even though in the end they're running on native operating systems threads, both virtual threads and coroutines, they're actually managed by the runtime itself. And, it just switches to the thread to execute things. So you can really see that throughput is a lot higher with both of them, where on the side of virtual threads, it is really good for kind of blocking when there's blocking things in between. You shouldn't like if you have very memory or calculation CPU intensive action. I don't think virtual threads in general is a good solution because it won't give away control. So, but in general, like Jose said, I don't think it's like a race between, oh, you should use this or you should use that. I think you should sometimes just look at what is the best for your specific situation.
Right.
Of course, virtual threads, they have also structured concurrency, which they build upon, which gives you a very nice framework. So that can actually, be a good reason to choose, again, if you have these really difficult use cases. Um, in general, I think both virtual threads and also coroutines also is a paradigm shift for developers in their mindset, because normal as Java developers, we were always told like, threads or running something is that's really expensive. So you should be careful with them. We should pool the threads and stuff like that. And I think what we see now is with both of these things that we can actually, calling a coroutine or calling a virtual thread is just as cheap as calling another function in your code. So it's also a mindset of where you want to use this in your application.
Right, right. Thank you. Now, Java is undergoing somewhat of a renaissance with the release of Jakarta EE11, which brings a modernized cloud-optimized platform, introducing features like Jakarta Data API and aligning with Java 21's virtual thread for scalable concurrency. So, Ron, given your experience with cloud-native migrations, what do these developments mean for teams looking to modernize legacy Java or Jakarta EE systems?
Yeah, I think with Java EE 11, I think the whole ecosystem made an enormous step because now for the first time, Java 17 is like the baseline language level. So we're really optimizing here. That means suddenly we can use things like, well, we can use the records now. We can use like the switch expression. We can use sealed clauses, all these things which added by Java uh, via Project Loom, they're now actually available to also use on the enterprise side. So I think that's already quite interesting. Like you said, there's this new API, Jakarta Data, which has this repository-based approach. And for people familiar with, for instance, the Spring framework, it's very close, but not similar, but very close to the repository pattern that Spring uses. So I think that is really good. They also came, well, they already came earlier with the core profile. So Jakarta EE has multiple profiles, and the core profile is very interesting because it's a very slim runtime that you're getting then, which means it's ideal for microservices based situations. But yeah, I really think that it uses great chances. It promises Java 17, as a minimum standard, but there's also this technically compatibility kit that goes to Java 21. And then you're right, suddenly virtual threads also come within reach. And actually using virtual threads, you have to run Java 21, of course, because there was the first official release where it was a final version. But there's this thing called managed execution definition, which has this property virtual. And if you only set that, you can actually use virtual threads in your Java applications or Java EE applications. So I think they're making a real big step there.
Right,
And
right.
about the migration part, just to get back to the question about the migration part, sorry, I think there's many steps that you can actually take. But if it is a simple upgrade saying you should first see, am I already on Jakarta EE at all, or am I still on Java EE? Now, if you're still on Java EE, then there's multiple ways to migrate your sources, right? There is this book, you're right, from Peck Publishing, where we actually outline a number of these things. There's tools that you can use. There's even dedicated plugins for IntelliJ, for instance, that can help you a lot. It's a lot about namespace conversion, but there's few other tricks as well. Now, if you are already on the Jakarta EE part, then I think upgrading is actually quite simple. And basically upgrading your Java version. And this Jakarta data project is actually quite interesting. And I think I would just advise architects and developers to say, okay, just use it. If you're building a new feature because it's completely backwards compatible with JPA, so it has the same, so there's nothing new or what you need to change that. If you write something new, if there's new database tables, just try to use this Jakarta data for those specific situations and services.
Right, brilliant. And Jose, I'd like your perspective on this as well. But specifically, do you have any sort of insights on how architects can best leverage these new tools, such as repository style data access and virtual threads, when migrating monolithic applications to cloud native microservices? And what are some common pitfalls they should be aware of during such a transition?
Yeah. For example, about the first part, the modernization, it's clear the enterprise is not dying. We are evolving everything. That's the first part because obviously a lot of people they love these phrases to put in a blog. No? But now I think that the enterprise is very clear. It's evolving. The idea is obviously we want to create very specific way good tools for everyone, and we want to create a good code to legacy because at the end you will keep use it. About specific microservice and monoliths, well, obviously you will find a lot of discussions on internet and Reddit and blogs and YouTube channels and everything about the w- what is better for your project or your company. The thing is, the problem is when you are just reading without the context, and you need to understand each context is different. I think that's the first part. The second is the microservice, in my experience, is not the goal, okay? Is the consequence for that. Because when you always see the microservice is the goal for each software developer or architectures, probably that's the issue, that's the problem. Because if you don't have developers with experience, you don't have good architecture definition, you will have microservice with the same problem with monolithics, because that's the thing. The other part is the monolith in these cases. The people is looking bad sometimes in some cases, in some things are good, and the monolithic as an old code. And obviously that's a lie, because you can use monolithics without problems with a huge systems, and you will see you can save the complexity or of the microservices. You can use monolithics to scale. Actually, you don't have to use always a microservice to scale. Actually, it's easy to understand and to maintain that's because you have less complexity, operative complexity in your code. So the question to use, hey, I need to use microservice, yes or no, because that's the thing. The For me, I always try to answer a question before, or maybe two questions to use it. We are prepared for paying the real cost to use a microservice, not just the money. I think about we have teams prepared to use this architecture or not. Because if you are doing this before you are with the knowledge for do that, probably you will have a huge problem, because it's not too easy to change your architecture, change your definitions, your business rules and everything. And again, you need to roll back to monolith because you are not prepared. That's my concern, obviously, when I work in a team and they are just focusing change microservice because they read in a blog. Okay, that's and this is my recommendation always.
All right. Thank you. So I think that was some really good insight on dealing with the extreme microservices complexity that, we are seeing organizations sort of paring back to monolithic structures now. So, Ron, I'd like to pick your brain on this. What do you think are some criterias or signals that help you decide if a modular monolith might be a better choice for long-term maintainability? And how does one manage the trade-offs for scalability and team ownership?
Yeah, yeah. Well, this is really kind of a subject very close to my heart because I guess we've all been through this wave. Like there was this FANG group, Facebook, Apple, Amazon, Netflix, Google, and they all came with microservices, right? So we thought, oh, this is the way we need to go. This is the wagon we need to jump on. And I think a lot of us did. And like Jose said, I think we also found maybe it's not the right choice because maybe you should ask yourself if you have 200 employees, if microservices is for your business the right solution compared to, can you actually afford it? Because microservices really on a DevOps part, they require a lot more overhead because there's a lot more monitoring involved. You need to watch these services, you need to see what is coming out. So there's a lot of metrics that is needed to keep them running in production. You need to, are they still running in production? Because before you had this one monolithic application, and a lot of things Jose said, like monoliths have become like a negative name, right? Like dinosaurs almost, which it isn't. I mean, it's still brilliantly functioning code running on application servers that have been there for a very long time. So there's nothing bad about them. They're just being opposed to, being old compared to microservices. So you have one monolith running, and that's easy to monitor. It's easy to do logging. It's easy to do debugging as a developer. You just attach to it remotely. But when you're switching to a microservices platform, you got dozens or hundreds of services running. You need to make sure each of them are still running. You need to somehow, if you trace a problem, combine all the logs so that you can actually, go through the logging and try to find out what happened. So there's a lot of work there. Trying debugging a problem with microservices. That will keep you busy for a bit. So there's a lot of things there that are happening, I think, where you have to be really careful. And yes, like Jose said, it should never be a technology choice, but it should really be a choice based on what we need. And I think from my experience, what I have learned is I would start with what I would call modular monoliths. So there's the classical monolith where all the modules, they're intertwined without very clear boundaries. If you have a modular monolith, basically what it would mean is you still have your modules, but they can't interact directly with one another. But there's a predefined API somewhere, and one module is only allowed to access another module via this predefined API, which really makes the code less cluttered and far less risky to change, that things will break. Because if I would go via an API, then the API will change and I will see it, or the API won't change, but I can change internal methods without something breaking there. So I think my suggestion would always be just start with this modular monolith, and just be very clear on your boundaries and have these boundaries enforced that we go through APIs. And that's just monitor the system, watch it. And if there's typical situations like if you find there's this one module, let's say customer module, that requires a lot of changes, which means a lot of redeployment, then that might be a case to say, well, maybe I should factor this out, make it a microservice. And combine the two. There's nothing against combining microservices with a modular monolith. Maybe there's a different, like you said, resource utilization, that there's more, it has different scaling requirements. Well, that could be another case where you say, okay, if this is really the case, maybe I should factor it out. But even then, I would say, look at how much the cost, and only when the cost of keeping it in starts to outweigh the cost of switching to microservices, I think that would be the moment to make this choice. But again, microservices, they require a different mindset. You're really also getting, the distributed tax that you're paying, and that can be really, really expensive, and you should be really careful. But I guess then we get into the realm of domain-driven design and bounded context, which might be a bit too much for now.
All right. Thank you so much, Ron. That was extremely helpful. Now let's shift to talking about adoption of Kotlin and Java dominant teams. So introducing Kotlin into an established Java code base isn't just a technical change, right? But it's also a cultural one. And Kotlin experts advise to win the hearts and minds of skeptical Java developers, not just through hard facts, but also via soft factors like easier onboarding and community support, etc. So, Ron, drawing from your teaching and leadership experience, what strategies do you recommend to gradually introduce Kotlin in a Java-centric organization?
Yeah. I think what you always find if you introduce something like Kotlin into an organization, I think you should be very aware, because there will always be some, like the gurus in the company, which are very focused on Java and which know the inner details, and they might actually see bringing in a new language as a threat to their supremacy. So I think most important thing is to get them on board, because in general, I would expect that like 60-70% of developers would be really interested and said, oh yeah, we're going along with this. So maybe it is not directly. What we sometimes did is that we had a team with some enthusiasts and some, critical persons, and we let them develop something new. It could either be, if we're doing microservices, I mean, microservices are brilliant for this, right? Because, you can choose whatever technology you want for your new service. So Kotlin would be a great choice there. So that would be a good thing to do something like that and say, okay, have this team of skeptics and enthusiasts, and then see how they work together on the problem. Because if you just do the one or the other, you're not really getting everyone on board. That would be a really good approach, I think. What I've sometimes also have done, you have this thing called advent of code, right? That is right now at this time, the period leading up to Christmas, and there's new coding challenges. Well, you could say with your team, you know what, we're going to do advent of code, and this year we're going to do it in Kotlin and try to see how we would work it out there. So that could be a thing. Of course, you can do things with hackathons in your own team and say, we're doing this coding sessions, and let's try to explore how we could use Kotlin there. And finally, I think if you would do actually code reviews with the whole team, you could actually go also through Kotlin and like gradually then explain, okay, what are we doing here and why are we doing it this way in Kotlin? And which makes people really see, okay, I've done it the Java way. And I think that really pays, for instance, collection classes, because Kotlin has such a great collection methods. And then people just in the code review, the skeptics, they can see, oh, wow, this is actually quite nice and very concise how we're writing the code. So enforcing it upon someone, I don't think is ever going to work. At least they'll probably do it, but they won't do it by heart. So I think in general, with these steps, you can actually win their hearts.
Right. Thank you so much, Ron. And Jose, I'd like you to add your perspective there and tell us, how can engineering leads support their team's upskilling and address any resistance and ensure a smooth transition without disrupting productivity?
I think maybe the good news or the bad news, that depends, but it's more about leadership issue in this case, because I think that we have a beginning very clear. We need to people saying the next steps for that. Because if you don't have this follow up about this leadership, probably you will see a mess in some cases. So that's good news, because if you have the person in your team, obviously it's a easy way to do that. But if you don't have it, you need to create it, or you need to hire these people, because that's the thing. Maybe you have people with good leadership, but without the knowledge for the adoption. Because, for example, the most common errors when you are trying to do that, you need to start with a small limits. Because if you're trying to migrate everything or the most complex in your legacy code, probably is not a good idea. So my recommendation, for example, in some companies when they ask for something similar, is start with the models with because you need to see if you think it's good writing code, that's correct, because they are working with you. But they really understand the business, because maybe you will see they know the new business, not the old business, for example, because you are using old code sometimes. The other part is it's a new language, it's a new paradigm, it's a new code. At the end, you need to see if you have problem with the adoption, because sometimes the people understand the features in not the real benefit. They understand the modern things, or they understand the faster way to do the things, but it's not the same. Is the best way to do that. So don't 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 be close for these situations, because obviously the most important is, okay, we will do the migration. I am not saying this is the best way to do the things, because probably the team can find a best way to do the things, because they are really put the hands on the code. But if you are very close with that, and you say to the team, just follow what I am doing, probably you will miss a good parts of the code from the team. So that's the other part. And just to code talk, okay? It's weird, sounds weird, but when you are using the a team for the migration, probably they are the best way to find the situation, to understand the situation, because you can imagine how the things is working. But when you are rewriting the code, you will see the real things. If you maybe you have a good code and you don't need to rewrite this part. Maybe you have to rewrite other module, not this one, because you will see the benefit, and maybe the benefit is not too good to change it. Maybe the benefit is in another module. Sometimes that happens because the problem is if you think the leadership or just one person knows everything about the project, probably you are not with the correct answer, because the people they need to put the hands on the code for that. And just to close that, you need to think in your team. In these cases, you need to trust in that team to take some decisions. Obviously, they need to explain to you or explain to the company, but probably they are the best way to understand the problems in those cases. And you need to give a space to the teams to play with a new toys, because probably they have the answers, but they don't know yet. So they if you let to them play with some new features or some new code, probably you will find a good things in that. And obviously, don't try to read the productivity in code lines, because if you try to read it as a good thing, if you have more lines of code or less lines of code, probably you will miss something. So in this case, my recommendation is we need to avoid the productivity is the same as more lines of code or less. Just the keep trusting in the team and decide together if it's a good part for the business, if we need to change something or not. But if you don't open the code and read it and trying to play with that, you don't know the if the adoption is a good idea or not.
Right. Thank you, Jose. Very insightful. And actually, probably the next couple of questions are also more for you, because we're going to talk about mobile development and cross-platform. Now, the Android development landscape has been in a constant flux. As of this year, we've seen the rise of Jetpack Compose for declarative UI, more sophisticated modularization of apps, and a renewed emphasis on clean architecture principles for maintainability. So, based on your experience building hundreds of mobile apps, what do you consider the three most important architectural practices or patterns for modern Android development?
I think the last 2 years we are really see why they think to use Start Kotlin. Okay, that's the thing. Uh, because for Jetpack Compose, I think that's the main concern. If I need to say three keys for that, I think we need to separate the responsibilities. Is a good part, even if you are not using for Android. But I think is if you can separate your responsibilities in the code, is always a benefit for everyone, for testers, for developers, for product owners, for everyone, because it's very easy to understand each part for everyone. Trying to use the definition of modules, not for because it's a new wave to do that. Maybe that sounds we need to separate everything, but because we need to do that. No, the thing is if you modularize everything in your project, it's very easy to add these features, add this model as a feature, or delete or change this model for emergency, for example. Maybe you have a critical bug in some part of the code, but if you have a models, you can just put in other part and you can continue with the regular functionality. So like I think that's the second. And the third one, I think the architecture is changing for the you need to prepare your architecture ready for a change because when we create code, we think the code we will be always the same code. That's the problem. I think I it's very complex. I just saw a very experiment people trying to create architectures ready for new changes because we don't have the time, we don't have the money, we don't have the team for do that. But I think if the great developers of the great leaderships, they are preparing always the project for a changes, uh, not just for the new framework. For example, in other is very obvious because if you prepare your project just for the new framework, when we change the paradigm, in this case for our Jetpack Compose, because it's a really different way to do mobile applications, probably all in your code is not is not ready to these changes. That's the deal, and that's the problem. So now you will see a lot of applications, mobile applications. The new features is working with Jetpack Compose, but the old one uh, probably they will never migrate that because they are not ready for these changes because you have too much complexity in this one. But if you decide to create a new application, obviously in the past it's very easy to have an opinion, but that's that's part of the question. You will prepare everything in models. Probably your architecture is very easy to understand because you can change the model one, model two, or model three to Jetpack Compose without affect the other models. Probably if a lot of applications did it in the past with a definition in models, probably they can migrate the code and they don't need to keep waiting a miracle to change the models just for the new Jetpack Compose implementation, for example. So that's my three keys. And in my context, in my current projects or last projects, I always ask, for example, when I will implement a new technology, what kind of problems we will resolve with that, the cost of the adoption, and the impact for a long term. That's my three main variables I have in mind, and I try always to put a number. How many problems I will solve, the cost of the adoption, how many people and how many resources we needed, and the impact. We will have an impact in long term or mid term or short term. I think with these three variables, I create a table and share with the teams. And after that, just after that, and have very clear situation, we decide if we need to follow these new technologies. That's what I did in the past.
All right, José. And I'm going to ask you the next question as well before we switch back to Ron again. So, Jose, with your background in Android, iOS, and cross-platform frameworks like Flutter, how do you see Kotlin multi-platform fitting into real-world projects today?
I think we are in a very interesting situation in mobile development right now because we have a lot of actors, maybe a serious actor, because in the past we have a lot of actors, but the problem is I am not a fan of JavaScript, but the problem for mobile development in the beginning for multi-platform is they have a lot of JavaScript frameworks. And at the end, it's not the same case because it's not a real multi-platform situations. But now we have a lot of multi-platform situations. We have Flutter, we have a Swift UI, we have Android with Kotlin, multi-platform. So you are really creating a code base for using in the other option of mobile development without to add some patches for these situations. So it's a real competition for who is the best option. Now we don't have a clear winner for that because that depends for each team. For example, if you have iOS team and you have 5 developers using iOS and Swift, why they need to learn Kotlin? Maybe it's not the best case for that. Maybe you have the Swift situation. That's the real thing, because you will need to pay, or you will need to use money for this migration at the end. But now we are in the most easy way to create multi-platform applications, even for mobile developers, even for Android developers, or iOS developers. So we have a real situation where we can separate the logic for the UI without problems. With Kotlin multi-platform, it's very clear to do that. You don't need to be expert on Android or Java or Kotlin. If you read the code, you will understand in a very easy way, even because we are using, when we write the code now, you will see a lot of web programming paradigms. For example, the reactive way to do websites with Vue or React, you will see when you read the Kotlin code in mobile development. It's very, very, very easy to understand. You will see Flutter is okay, React Native is okay, but at the end, Kotlin is part of the body of mobile development, and Swift in this case too. So we need just to wait maybe a couple months or maybe a couple years to see the real impact about the Kotlin multi-platform. The way to understand Kotlin multi-platform is very easy. If you understand Kotlin, you don't need to understand too much. Probably you will need to take 2 or 3 features, because maybe these features is not too famous in backend development, for example, or in the Java world, but it's 2 or 3, not too much, because at the end you are using your regular Kotlin in backend. You can just use it in mobile development. The problem is you need to understand how the operation system is working. That's the only thing. The tooling is very advanced. That's the other part. You will see Kotlin multi-platform maybe is running too fast for these changes. They are creating and sharing tools each 3 months, 4 months for the people, the ecosystems, and Kotlin too. So it's very, very good news for the developers, because you will see 2 or 3 really good and maturity tools each 4 months. So I think that's the advantage to use Kotlin multi-platform for mobile development versus Flutter or React, even if they have more years, because now they are in other stage. They are trying to increase the developers in the ecosystem of Flutter or React, but Kotlin, they don't need to do that, because they pass this stage. Because if you are using Java, you can use Kotlin. If you are a Kotlin developer, you can use Kotlin multi-platform. I don't need to convince you to use it, because I don't have the problem with the knowledge. You have these tools. Just why are you are what the question is, why are not you doing or creating mobile application with Kotlin multi-platform? That's the real thing, because you have the knowledge. You have Kotlin, you have Java knowledge. Maybe you just need to take a look about the operation system. I think that's the real situation for Kotlin multi-platform. They are just waiting more people in the ecosystem, because if you know Kotlin, you can do that.
All right. Thank you, Jose. And now I'm coming back to Ron. So, we've been talking about Jetpack Compose. We've been talking about Kotlin multi-platform, which are sort of, you could say, new technologies or new approaches. And we talked about them in the context of adapting them into large-scale apps. But when it comes to a large-scale enterprise setting, what challenges should teams be aware of when adopting a new technology or approach, while they aim to, access benefits such as maximizing code reuse without compromising native user experience and so on? So what are some best practices or difficulties even that teams should be aware of when trying to bring something into the stack, so to say?
Yeah, that is an interesting question, because I guess one of the core reasons also for Kotlin multi-platform to be there is like code reuse, and specifically if you have business logic, that's really the code you don't want to have distributed over different platforms, but you would like to have centralized. So I think everything goes down there, and that you should really focus on which part you really think you should share. And because if you look at code reuse, and especially in enterprise environment, I mean, reusing parts, it depends on your architecture, doesn't it? Because if you have this like classical architecture where you have one large single deployable unit, then code reuse could be quite easy. If you get to, well, the microservices situation, well, then code reuse becomes a little more tricky, I think. And then, the whole drive thing from don't repeat yourself suddenly becomes a bit more fluid, that you can say, well, sometimes we just do want to reuse in order to maintain the independability that microservices should have. So again, here, I think it all depends upon what is the architecture you're trying to support. So I think there's no one fits all solution here. So no.
Right. All right. Thank you, Ron. That was brilliant. And now it's time to talk about your book, I think.
Finally.
Finally, the most exciting part. So, Kotlin for Java developers is aimed at software developers proficient in Java who want to learn Kotlin for professional development. And it's especially relevant to Android engineers, JVM backend developers, and full stack Java programmers maintaining legacy systems. So, Ron, I'll start with you. What inspired you to write this book alongside Jose?
Well, the good thing is actually, well, Jose actually did the bulk of the work. It was already there, right? So I actually came later to the project. And so the majority of this book and the credits for the book should really go to him, because he had already written a large part, and I think I only added a few chapters. But I think I came to the project for a simple reason, that because anyone who writes code, if you write code and you can have like 10 developers and you say, write this piece of code for me, then you'll get 10 different solutions in the end. Could be typical small things or something, but everyone has their own style, and you can always see it with code reviews that shouldn't we do it like this? Why not like that? And I think it was the same here with the book. I think Jose had already written the majority of the book, but just like with code, it's always good to have a second opinion about it. And that's basically where I came in. So then we started, chatting with one another and talking about, okay, should we rewrite it like this? And is this better? Or, so just fine tuning a lot of things and having two perspectives to the book. So that's how I got to it. Or actually what I did in the book, how I got to it was easy. I was approached by Peck. So, said, we have this book about Kotlin. So I thought, yeah, Kotlin, that's great, and then that's really something that really touches me, which I think is a great technology and which should be used more often. So yeah, if there's a way that we can spread the good news, I would really love to do that. And then I got to see all the work that Jose had already done, and I thought, well, this is just brilliant, and yes, I would love to be a part of this. And yeah, I just hope that Java developers really see it. What I really liked about the approach to this book was, it's not like I'm telling you Kotlin from A to Z. I really love that we have this approach where we say, wait a minute, you're already a developer, you're an experienced Java developer. I don't need to teach you what loops are or iterations or in general what functions are or lambdas. You already know that. I'm just going to teach you how you can make the transition to Kotlin. So that's why I think, because there's a lot of information in there for Java developers in a very concise way. So it'll save them time if they use the book to switching.
Right. Thank you, Ron. And Jose, what was your inspiration? What specific gaps, common struggles did you observe among Java developers that made you think, I need to write this book and I need to help them?
Well, I need to say something at the beginning now because Ron say I started the book early, but yeah, that's true. But actually, that's very important. The part of Ron because for the project because I actually I was very some stuck in a couple things, and actually he read it and he make the record suggestions, and I think that's a way point to trying to move forward because obviously we have a lot of complexity situations to understand. I read a lot of books in the past, but this is the second English because it's not my main language. But obviously that helps a lot. I think maybe not for him because he's very good with English, maybe, but no, not for me because I think that's helped a lot for that. Well, about the Kotlin, when I start when I start thinking about the how I need to solve or I want to explain the things. I know in the past I am a teacher too. I was teacher for 18 years maybe. And I know, for example, when I try to tell the people at the beginning with 18 years, but it's very easy. It's not the same case when you have developers with previous experience. So I take that in my mind because I know a lot of people what they want to use Kotlin is because they are coming from Java. That's the part. This is a different way when you are starting from zero or scratch, but you have developers with experience. It's a very different way to do that. So I take in mind that when I was reading the book, I was thinking too much in that. The other part is I need to take time to explain the syntax, but at the end, the problem is the way we will try to focus the situation. For example, I am trying to explain how we can write this line of code in Kotlin, or maybe we need to think we really need this line of code because maybe in Kotlin we don't need it. That's I always trying to put the question in the reader mind. If we need it, okay, this is the way to do that. But the question is, we really need this line because maybe in Kotlin we have another way to do that, and maybe we don't need to use it. That's my second question always when I trying to explain something, because I think that's the real way to create the bridge for Java developers to Kotlin. Okay, maybe you will need that knowledge. More baby is better if you don't need it, but you know why. You have the answer, or maybe you need to find the answer when you are writing the code. That's the other part. The other question and or comment I always have in my mind is we need to be respectful with Java. Since the beginning with Kotlin, when we try to sell the idea to use Kotlin, I don't like too much. Actually, I have a very weird experience in the past when I was Google Developer Expert and I was the third or the number four Kotlin Developer Expert. And the problem is they they rem- they remove me for Kotlin Developer Expert because I'm not always saying the best option is Kotlin for the developer. And I really think that in some cases, because maybe you have situations when you don't see a very specific answer or a good answer for that. But is the real part. We need to be respectful with Java because at the beginning, without the experience of Java, we can't create Kotlin. Not me, the team of Kotlin, because obviously they use a lot of experience in Java. All of them, they are a very experiment people with Java, and they try to see good parts of Java and take it in Kotlin, and they are increasing the good parts. So if we sell Kotlin as a killer, Java killer, I think that's respectful for the technology because it's not the way to do that. Sometimes it's actually is a complement for the technologies, the architecture, the projects. But the other part is more than you. Sometimes it's just your preference, how you will prefer to write the code in this way or this one. because maybe you don't have very clear this architecture or this paradigm to use it. So that's the other part. I always use my way to express the if you need to compare Java with Kotlin. I always try to be very respectful with that, because a lot of the good things in Kotlin, maybe 90% of them, they are coming from Java, because Java is the first part of your experience. So I always try to keep in that mind when I write in the book and put the examples. Obviously, we have a lot of parts better in this case, or very fast implementation. I need to say it, obviously, but with the correct words and the correct approach for the people. For me, that's my line to follow to write the book. And obviously, I want a couple parts. They are really practice in these cases. I use a very simple scenarios and adding complexity in the code. I start maybe, for example, with just one definition, but at the end of the chapter, you will see 6 more functions, because that's the way to follow up. I don't prefer to do anything by default, because when I read books in the past, I'm not saying all the authors and all the things, you sometimes see magic code is just appear in the next page. So I don't like too much to say, hey, we have new code, just read it and move forward, because I don't think that's the way. Obviously, in other kind of books, on another kind of technologies, maybe you need to do that because it's a framework and needs to be, and you can pay the template because it's too. But I try, even in the necessary parts, I try to do that for the book. That's my maybe 5 or 3 points to follow when I write in the book.
Brilliant. Thank you so much, Jose. And I think we wrap this up with Ron. And I'd just like to quickly ask you, Ron, according to you, what do you hope experienced Java professionals will do differently after reading Kotlin for Java developers? And how do you think this will help them tackle real world challenges more effectively?
Um, well, I think, again, like we said, this is really trying to explain to Java developers, like, Kotlin isn't that different, because, like, again, 80% your logic and things will still be the same. Yes, you will use a bit different syntax, but it's still a syntax that's quite familiar to you. You might use different collection functions because there's different ones. But I think the really important part here is that you're actually starting to see the value, but you're also starting to recognize, wait a minute, it doesn't really matter if I do Java, if I do Kotlin, they're both running on this brilliant thing, which is the JVM, right? The Java virtual machine that in the end runs the code. And so it is not as big a step as you might think it is when you move from Java to Kotlin, as you might be like moving from Java to Go, or from Java to Rust. So the steps are really small, and I think our book just helps you, writing this idiomatic Kotlin, where you can actually see, oh, right, I'm actually seeing what I should do. And like Jose said, it's not like translating it one to one. Actually, I think JetBrains in the IDE, they have this function where you can say select Java class and say convert to Kotlin. Well, that would technically work, but it still wouldn't be idiomatic Kotlin, right? So I really hope that with the book in hand, you would actually write more, well, Kotlin as this is meant to be. So I really hope that's where we're getting.
Brilliant. Thank you so much, Ryan. And that brings us to the end of this conversation. Jose and Ron, thank you so much for joining us and sharing your insights and bringing Kotlin into serious Java code bases. I think your perspectives on migration strategies, team adoption, and the realities of running this on the JVM in production have all been invaluable. So thank you very much for spending this time with Deep Engineering.
Pleasure to be here.
Wonderful.
Thank you, and I hope to see you again, Ron, actually.
I hope so.
Thanks.
I hope we
Likewise.
have. Yeah. And to our viewers, thanks for tuning in. If you'd like to go deeper into the topics we covered today, do check out Jose and Ron's new book, Kotlin for Java Developers. Yes, you can see it shining in Ron's background. We'll drop the link for you along with links to their talks, articles, and some almost open source work. Until next time, this is Divya for Deep Engineering.